while I get the mic, I can maybe tell you that my background is that I'm an engineer working with automation and control systems, and also working with some district heating turnkey projects we made in business in China and Mongolia. And now for the last 10 years I've been sales manager in ABB Denmark, taking care of utility customers in both combined multi-utilities and power production and the automation for these customers. That's more or less short story. And I'll try to give you an idea of what we are facing related to cybersecurity. Cybersecurity is
the remote guy can't hear you.
Okay. No. Yes. Yeah. Yeah. So I guess we are running now. Yep. You can all hear me. Also, the ones following me on the web. Cybersecurity is we're going to look into the current, future challenges and how to protect our systems and how to mitigate these threats that we are looking into from cybersecurity attacks. You all know, I'm sure, about this, and a number of examples we see here. Some years ago in the uranium business, the Stuxnet was placed there and destroyed the machinery. It was German steelwork that was attacked, and then tradition every Christmas that someone is making a blackout in Ukrainian power supply. We will see if the tradition will continue this year in December, but probably it will. And this is only a few examples of what we see today. And a recent example from June this year is the shipping company Maersk, the Danish global player on this, maybe the largest player on this field, Danish company. An example of it's not small money we're talking about. They had a direct loss of $300 million US. They were down in 1 or 2 weeks. Basically, they didn't know where the containers were. And this was only the direct loss. Then they had the image loss also, because Maersk is known to supply in town. They couldn't do that. So it's just to illustrate what we are facing. We have seen in the customers that we take care of during the last 2 years increasing success for people who want to interfere into not only the IT administration system but also the control system. And it wasn't quite common just a couple of years ago that they succeeded by this, but we have seen, I think, the last year, 6 or 7 utility companies being hacked or being hit by ransomware to interfere in the control system. And that's, of course, one of their main concerns for us, and probably also for you. That is to lose control of production or distribution or whatever is the business. And just to show that this is not the way to do it, this is you see in the arrow here that the French TV channel put their password for their YouTube account on a poster that could be seen from the television program, and not the best way of doing it. So they had to close down the program, and their website was hacked shortly after. So be careful. And I know that it's not maybe so common to share information about when you've been hacked. We've seen that for our customers. They don't want to tell about it. They want to keep it inside. But this is also changing, and new regulations, for instance, in Denmark now require that every time you have in your business an attack or you have a fighting, you have to report it to authorities, to the intelligence service, to keep track of the threat. So, what about you? Have you experienced any thing in your systems? Attacks? So you are better than the average? That's good. But it is increasing the pressure from outside. If we take this small unit here, if you take a unit like that and you put it on the internet, just some device here, intelligent device, how long time do you think you have to protect it before someone tries to break in the first time? Have a guess?
5 seconds. A day? Very small time.
Something in between. You have 3 to 4 minutes before the first average. We have used an external cybersecurity expert. He has tried to test this. You have 3 to 4 minutes. Then the first one is trying to interfere into this. And this is just to illustrate.
Are those people or is it?
No, not necessarily. You can buy these software on the black internet for maybe 50 or 100 US, and then they just start scanning. You're just scanning what are the open access points. Yeah. So that just illustrates that never put your crucial equipment on the internet without protecting it first. That's the first learning. Let's go a little bit more into the cybersecurity challenge. We have already looked at that. Let's look into some of the basics of cybersecurity. The problem occurs when you see some system failure due to any of these things. Targeted attacks, that's hackers trying to get in. In the business they discuss about white hackers, white hat, grey hat and black hat. Good guys, bad guys, or in between. So the most dangerous course, the black hat hackers who try to get in to destroy or to get money. Then there's a lot of other ways to get threats into your system. Malicious software, this could be virus, this could be worms, ransomware, whatever, and it could be a USB device. If you find a USB stick on the parking lot saying payments for employees, many people will put it into a computer to see what is your colleague's wage, but it could be an attack. Or the most common, of course, is, for instance, ransomware. It comes in a mail, and when you click on it, you have a problem. But also, what is often not considered is a mistake by employees inside the company. Not necessarily bad intention, but just making a mistake. Open up something, downloading some program, software, whatever. This is also very important to have this third part as your considerations regarding safety. So, what is also often considered in just a couple of years ago is that if you only have a firewall and you have some antivirus software, then you're safe. This is not what cybersecurity is about. It's much more perspectives in it. The outer layer here is the physical security. So if you have installations around the city, the area, your factory, whatever, is the doors locked? Are the doors locked? Can you just get in and find an Ethernet port and get access to the network? Are your programming PC or devices, are they locked or is it open? So physical security is one of the measures that's important. Of course, firewalls, and we will come back to that, architecture, how you build your system, is also important. But there are all these aspects you have to take into account. Also that you use individual passwords or access rights and passwords for each person. Don't share it. Don't have a user just called operator and then it's always logged on. There are a lot of measures you have to take into account, and of course then the inner layers, antivirus and security updates of your software. But there isn't 100% secure systems. We will never have that. And cybersecurity is not something you can buy and say, I buy this box here and then I put it in and then I'm safe. It's changing all the time, as you could see of the thread I explained before. New ways of interfering in your system is being invented somewhere in other countries or in our black cellar, I don't know. But it's an evolving target, it's changing all the time, so it's being up to date is important. And then it's about also about cost. Because, of course, if you have all the money in the world, you can make a very, very safe system. But there's a balance. So where to use your investment in getting cybersecurity, of course, the places where the risks are high. So it's also about risk management. What are the biggest risks? What are the costs? And find a balance. You will never get a perfect system. And then another issue, let's take an example from Danish energy company running primary power plants, but also electrical distribution and wind farms. And they say, of course, protecting against cybersecurity is very important. We still have to do that and keep doing that. But that's not enough, because it's only a matter of time when we get hit by cyber attacks and somebody succeed interfering with our system. So it's a matter of time before something breaks down, and therefore a disaster recovery plan is very important. You know what to do when it happens, not just try to hope that it doesn't happen. And that can be many things. For instance, we have learned that together with our customers that backups you have to have a backup of your software and your settings and your things offline, because if it's a network connected device where you have your backup, it will also be affected quite surely in a cyber attack. So an NAS device is fine, but if it's connected to a network, it might be affected. You need to have an emergency plan, because if you're having a lot of plants, for instance here this company has power plants all over Denmark, what will you do when you're attacked? Are you attacked on the upper level to cut off each power plant, or is it only one power plant that's attacked and you have to isolate that and can continue the rest? Everybody working with these systems will have to know what to do. You have to rehearse it, because it's not, if I called them today and said, what would you do if you attacked? They maybe didn't know. Some would say, I will cut out this connection, maybe it's not correct. So a disaster recovery plan is very important, and to let everybody know what to do and try it if it works in practice life. What we have also discussed with them is that it will be maybe necessary to have a shadow control system, meaning simply an offline copy running system, not connected to anything, but simply maybe in our ABB office, to have a copy of the system fully updated and ready to simply take it out of the rack, drive to the power plant and put it in, and then skip what is there today. That might be necessary for the critical plants to be able to keep up electrical supply to Denmark. Just an example. And then again, the cyber security approach, not only from ABB point of view, but in general, is about the product. When we say it's about the project, then it's when you use equipment and systems throughout a design and implementation of a new system, or an upgrade, or an extension, you have to have cyber security considerations in that process. If you run a project and you forget about cybersecurity, you might drag some cybersecurity threats into a new system that you don't know, and then they pop up later. And of course then in the maintenance and operation phase, how to maintain the cybersecurity defense. This is use a little time on this because this is the basics, you could say. There's a lot of standards, IEC standard for instance, that gives a good help what to do, what to consider. So maybe we will recommend to start with a risk assessment. Find out what is the current situation. Where are the big holes in your defense, per se? What to do first. Management buy-in. Here was a little bit mentioned on that. Maybe management do not understand this. Maybe management do not support investing in this. And if you don't have management support, it's very difficult to keep the defense in place. So try to get a management understanding, try to get a management support. Then you have to make your plan, your security policy. What is critical for your system, for your business, and how will you do? And by that you also have again to balance safety against cost. Always have to do that if you like it, if you like it or not. And then you have to work with your system suppliers and require that what you have of products and systems will be ready for protecting against cyber attacks. And again, these recovery plans, train your staff, check your policy all over again, and this is a process that should be continuing, just like you make quality control, quality assurance programs, safety programs for working conditions and so on. More or less the same here. And then, for me, I believe this is a very important issue. Normally or traditionally, we have considered systems to be what we would take care of cybersecurity. IT network, control system, maybe other operating or management systems. But also remember the products. It could be a Yumi robot, it could be a network switch, simple network switch, relay protection in power distribution and transmission, RTUs, frequency converters, controllers, PLCs. All these components will most likely be connected to some kind of IP network. Therefore, the software in all these equipment will have to be updated because there will be loopholes, there will be holes in the software ports, the things that can be attacked by the most advanced hackers, whatever it's a young guy in the cellar or it's an intelligence service in another country. There are somebody studying these products from not only EVB, anyone else, to find out how can I attack this port here, can I use that for something and get this way into the network and then into the company. So these products are just as important as the systems. Yeah, more or less what I have been saying. So update these firmware, basic software, whatever it's called, is also important. And we are also now supporting this by giving new updates of that. And the tradition for many of these product areas have been, like I say up here, the machine mindset. I buy this equipment, I install it, and it's a machine, it should be running for 10 years, and I don't have to care about rest. That's not valid anymore. You have to update it because it is IP connected, it's some kind of IT related. Also the configuration tools, often there are some PC tools to configure, set parameters in a relay or program PLC or whatever. And it will also often be connected to IP network or on and off. Even you keep it in a drawer somewhere. So this software will also have to be updated. It's of high cost, but it's necessary. This was about the standards. We talked about a little bit about that. These standards give you good advice to build up cybersecurity defense. For instance, focus on integrators and operators what to do, and focus on the systems you have and the ones supplying the system. A number of good guidelines. Recently, there were a new regulation in Denmark imposing strict requirements to everybody producing or distributing electrical power. And they simply we have to follow these new guidelines. I know there's not such regulation yet in Iceland, but I'm sure it will come. So you can also look forward to that. Not so much into this, but again, what we have to focus on as supplier, and you also have to focus on as system owner, is that, this is especially us, that our product design, we rethink cybersecurity into the design phase of the products. We test it and get independent testers to test our products for cybersecurity. Security by default, meaning that when we configure or install the system, program the system, or put parameters into a component, that we take care of, for instance, not opening communication ports that is not used, to set parameters so that we only have the minimum risk of attack for cybersecurity. It's about configuring, building systems and things so we take the best precaution already when we design it. And then, of course, during the lifetime, we come back to that and we updates. One of the things is that we strongly recommend that all users have their own user access, their own password, use standard Windows setup for user access. I know it's not so common on control systems in a control room, for instance, but this will be necessary in future, I'm sure, that you have your own password and have log over when you have shift. Yeah, our people also say it's a little difficult, but do it anyway. Building the system, this could be any SCADA system, control system, whatever, it's just an example of it. And the idea here is to make different network zones or segmentation so that it's difficult to come from out here, the internet, go through these different firewalls and switches. Don't make everything just one network. Make segmentation, make demonetized zone, different zones, so you have to go through different levels if you want to attack from outside. Take care of your firewalls, make a secure communication between the controllers, and have antivirus protection on your Windows machines. Have, again, role-based access control. Only give your staff access to what they really need and not to everything, for all of them. Security updates. Make sure that the patches from Microsoft is installed in your system. Make sure that it's validated by the supplier. Us, for instance, we have a service to validate and test all the patches from Microsoft and the antivirus updates, that it will not harm the system, to test that it's okay, and make sure that you update your system. Make sure you manage your firewalls. The firewall software will also have to be updated. Take a backup of your firewall and switch settings so you can restore it in case of attack. And use the supported Windows platform. We see that a number of control systems is actually running on older Windows that are no more supported. Windows 7 is still supported, but only for a couple of years, to take an example. So if you have a Windows-based system with an old version that is not supported by Microsoft, it's a no-go. And for instance, the power company in Denmark I mentioned, they have said that no one in their business is allowed to use systems on old platforms. So we have updated a number of systems during the last 2 years. And all software should be approved by the supplier. And risk assessment and maintaining your system. Again, this model here is to say that you could have a great advantage of cooperating with the system supplier and other external people maybe that could give different view on your risk. You could plan and customize your system and your testing, installation, configuration by specialists, and then the ongoing monitoring and maintain your cybersecurity measures. This could be a way to start. We have an offer of what we call cybersecurity fingerprint. This is not only a system testing, but it's also, if it's an AVP system, we can test what are the settings of the system, what are the Windows software updated, are the antivirus, are there user passwords, these the IT technical issues, but also an interview with the users. How do you use it? Do you change your password? Do you have your doors locked? All these issues. And then we add all of this information together, and we can come up with a spider diagram in a cybersecurity fingerprint report. And the issues here is, here you have a high risk, here you have a low risk. So you get an overview of what is your current status. This is a good way to start. You can see where you should start to improve. You can document to management what is the situation, what is the need, what are the needs, and you can, from this, you can work out a plan on how to improve. So that is a recommendation. And about the software updates. Microsoft software, antivirus, whatever, the McAfee or semantic that we often recommend. Should it be updated monthly or quarterly? Should antivirus be updated daily or monthly or other frequencies? We are seeing the requirement of this is increasing. Only a couple of years ago we said, well, it's fine to update Microsoft every year. But now we have customers who require us to update every month. And to improve that, we often use what is called a Visus server, a Windows service update, where we have a server where we push the updates when we have tested them for a system. We push them to the server, and from the server it is being pushed into the control systems, operating stations and servers. So it's an easy way of pushing both Microsoft updates and antivirus updates into the system, so that we maybe not need to go to each plant, to each installation to update this. So it's a way of saving costs to use these update servers in relation to the control system. Like this, we test and improve. Through a secure connection, we push it to the Visus server, and from here it's automatically distributed to the computers. More or less the same I have said, so it's about more about frequency, how often can we do this, and you can see that on our website. Remote access is also a big issue. Most systems require that service engineers, suppliers, staff, like us, AVP staff, will have some access to help to engineer, to update systems. And this remote connections is, of course, one of the threats to the system. So there are different solutions. We have established a certified setup here, where we from our service center can connect, but only authorized people using encrypted line and secure measures to connect, that certain ABB staff or service engineers are allowed to access this plant, but not this plant, for instance. So that's a way of doing it. It's a secure connection. Of course, other like VPN, SMS coding, and double authentication is also valid, meaning that you have login and you have VPN secure connection, and then when you log in, you get an SMS code personally back, and then you fill in the code, and then you have access. That's also a secure way. Have to be taken into account, because this is one of the easiest ways if there's an open remote connection. In the running system, it can be a good idea to monitor what's going on. And this is Service Port. It's a platform we have developed to run a cybersecurity application that is testing the system and giving key values, KPI values for all the cybersecurity issues. Have there anything happened since yesterday? Are there running new software? Are there ports open? Have you forgotten to remove some software? Whatever. So you get a picture every day. It's not an ongoing, like within 2 seconds can say now somebody connected in an IP address somewhere. But it's a software that is checking the system maybe 1 time a day and give you a picture of what is abnormal. Then you can, on this user interface, you can click on servers and say, okay, something's wrong with the servers. I click here, I get a list of the servers. I can see this is server number 17, and you can come down and see the detail. Because there's so much information you have to handle that it's needed to have a software to help you. So this is monitoring software finding abnormal situations in the system. And it's just running on the server, testing on the control system. About communication, we have a abb.com/cybersecurity webpage where you can find a lot of information for different business areas, and you can also find alerts that we have found, because it's also important to exchange information in an intelligent way about if there are some alerts of vulnerabilities we have found. We of course take care of informing our customers before we put it on the public web, or else we could help hackers. On the other side, if you find anything in our products or in our system, it's very important you let us know so that we can act. And therefore we have to have a good communication, or open communication between our customers and ABB development centers to be as fast as possible to make these changes that is needed if we find any loopholes. So you can go to this webpage and you can find your alerts about that. So, summary. It is a massive challenge. I can't say it too many times maybe. And it's a moving target. It's not just one way to do it. We always have to keep up with the current situation. Please remember to cover your products also, and not only the IT network system and the media control system. Analyze your current status and make your plans from that point. Because if you don't know your current situation, it's very difficult to prioritize your investment and your actions. And use some standard to base your method. Use some international standard, use some guidelines to help you in that process. And select some products, some systems that you're sure can be updated. It's not the best investment if you buy things, products, systems where there's no update to it. finally some cybersecurity regulation will force you to check it out of your system someday if you can't update it. Individual login and password, I have mentioned that. Consider how your system is built, network-wise. Only make the connections and access which is really needed. Update all your equipment on the network and your firewalls concurrently, and update your Windows platform with patches, maybe every month, maybe every quarter, whatever you find is needed. And then about the backups. Make sure your backups is not a target for hacking. And if you have a very critical process, you might consider having such a shadow system that you can use in case of attack. Simply take out your operating system and put in your backup. And then follow the communication on your supplier's webpage, and please give us your information back if you have any findings. And it's also highly recommended in the future to have some software that is monitoring your system and giving you alarms if something unusual happens. So cybersecurity protection is an ongoing process, and we of course happy to help you in that process. We believe we can add value to that. That's about it. I hope I didn't scare you too much.
Yes, you did.
Okay.
That was not the intention.
Not the intention, but anyway, it was the intention to bring out our experience. We have seen, as I said, surprisingly many companies being attacked this year. But anyway, contact me. The presentation should be available for running, and if you need more information, my email and telephone, please keep in contact. Questions about the scary things? Yes?
You mentioned cybersecurity by design.
Yeah.
How is BB doing when they are designing components? Are they reusing some design for example, internet connections to other components, or are they always designed from scratch?
Within each business area, we are using a high degree of module-based. For instance, all kinds of instrument frequency converter. You will see also that a lot of the software is the same, and therefore also the communication software is reused and tested. I don't know if I answered the question correctly.
Yeah. I think about we have an example from Samsung, who was producing refrigerators.
Okay.
And they took a sound system from their sound system, a sound module, and put it in the refrigerator to get the internet connection.
Okay.
But the refrigerator had a sound system in it with a microphone and a...
Okay. Yeah. So that's the disadvantage of reusing modules, you could say.
Yeah.
Yeah. That's why we have external, I have that on the slide I have taken out here because I only have half an hour. We are using external testers also, not only ABB testers. Things like that should come up when you test things by independent test centers. And yeah.
And to answer some of your question might be that if we have a module that reuses, as Per says, we use the same internet connection, for example, or connectivity module for our different purposes. Then if we find it not applying to the rules we have for cybersecurity, it is very, very strict, then we redesign it. And we have a very long test process in order to test if it's protected enough. And if it's not good enough, you have to redesign it. So that's what we mean by design. I heard that story as well, that you take some module that for something completely different and you put it into a wrong equipment. But we try to avoid that. And every single product we do, hardware product, software product, doesn't matter, has to go through a very specific and very harsh test for cybersecurity. So we try to bang it and see if it go down, how easy it is to get into it. It's a long list of stuff we have to do. It is, trust me.
We are proving.
Actually, it's very hard to get a new software product on the market because we have to do a hell of a lot of testing before we allow to do it. Which goes for you.
Yeah, you could say that the new versions of software, both for products and for systems, are actually these last 2 years. The main changes have been related to cybersecurity, some kind or the other. How can you download a software to a controller, for instance? Now the possibilities are limited, maybe restricted if you come with a different computer with a different IP address than you used last time, and things like that. So it is major improvements in cybersecurity, but nothing is perfect. So that's also why we need your feedback if you find anything.
Actually, I have a question. What happened to the smart sensor?
I use it. I'll show you.
Oh, okay. It might be somewhere.
It will be here somewhere. Yeah.
Thank you.
Thank you very much for your time.